In this video, we're going to look at indices. So first of all, some terminology, and we're going to use an example to just explain this terminology. So we've got 10 times 10 times 10 times 10, and we can actually write this as 10 to the power of 4. And we refer to 10 as the base and 4 as the index. Now, the index can also be called the power or the exponent. And we also may use the term indices, powers, exponents, and indices is just the plural of index. So there are 6 rules of indices that we're going to look at. Rule number 1 is for multiplication. So when multiplying two numbers with the same base, we just simply add the indices. And we can exemplify this with the following example. So if we have 2 to the power of 2 times 2 to the power of 3, that just becomes 2 to the power of 2 plus 3, or rather 2 to the power of 5. And we can see why this works by expanding everything out. So 2 to the power of 2 is 2 times 2, 2 to the power of 3 is 2 times 2 times 2, and 2 to the power of 5 is just 2 multiplied by itself 5 times. And if we multiply the 2 to the power of 2 by the 2 to the power of 3, we can see that those two are equal. Rule number 2 is dividing. So if we have a to the power of n divided by a to the power of m, then that will equal a to the power of n minus m. So when dividing two numbers with the same base, we subtract the indices. Again, we have an example for this. So we have 8 to the power of 5 divided by 8 to the power of 3, and that will equal 8 to the power of 5 minus 3, which is 8 to the power of 2. So if we multiply all of these out, 8 to the power of 5 is just 8 times 8 times 8 times 8 times 8. So we've got 5 lots of 8s, and 8 to the power of 3 is 8 times 8 times 8. And that will equal 8 to the power of 2, which is 8 times 8. And the reason for that is that we can cancel out some of the 8s. So 3 of the 8s in the numerator are cancelled out by 3 of the 8s in the denominator, just leaving 8 times 8. Rule number 3 is brackets. So if we have a to the power of n all to the power of m, we simply multiply the two powers together. And again, by way of an example, we've got 5 to the power of 2, and then that's all raised to the 5 to the power of 3. So the answer will be those two values multiplied together. So we have 5 to the power 2 times 3, which is 5 to the power of 6. If we expand this out then, 5 to the power of 2 is 5 times 5, and then because that's to the power of 3, we have that 3 times. So what we end up with is 5 being multiplied by itself 6 times. Hence we have 5 to the power of 6. Okay, the fourth rule is power of 0. So any non-zero value raised to the power of 0 is equal to 1. And again, we've got some examples. So it doesn't matter what the value is, as long as it's non-zero. If we raise it to the power of 0, we get 1. Rule number 5 is negatives. So if we raise a number to the power of a negative value, then that will equal 1 over that number raised to that power. So when an index is negative, we write its reciprocal to make it positive. And the reverse is also true. So if we have a to the power of n, that will equal to 1 over a to the power of minus n. So again, here are some examples. 10 to the power of minus 5 equals 1 divided by 10 to the power of 5. We can also do this with units. So centimetres to the minus 2 is equivalent to 1 divided by centimetres squared. Seconds squared is equivalent to 1 over seconds to the minus 2. So this is just the application of this rule number 5 to do with negatives. Final rule is radicals. So if we have root n of a number, that's equivalent to that number being raised to the power of 1 divided by n. So the nth root of a non-zero value is the same as raising it to the power of 1 over n. And again, for example, we've got 27, so the cube root of 27 is the same as 27 raised to the power of a third. Okay, so that's been a video about indices. I hope you found that useful. Please remember to like, comment and subscribe, and thanks very much for watching.